Hey everybody, welcome to Maths Unraveled. Today I am solving the mock test paper for Primary 5 and this is for American Mathematics Olympiad. So if you're preparing to give this exam soon, taking the mock test paper will be a really good idea to get some practice. Just to give an idea, there are 25 questions. The time allowed is 1 hour 30 minutes and there are three different sections. Question to 1 to 15 are 3 points each. The next section has 5 points each and the last 21 to 25, 5 questions, 6 points each. No calculators are allowed. Let's begin. Let's begin. This is question number 1 of section 1, which has 15 multiple choice questions. Each question is 3 points each. This should not take more than 1 or 2 minutes for each question. All right, let's begin. Brenda multiplies a number by 3, then adds 3, then divides by 3, adds 6, and subtracts 6. So she's doing a series of mathematical operations. From these, she gets the result 9 at the end. What is 6 times the original number? Now, in order to find the original number, and because we know the end result, 9, is a good idea to start from 9 and work our way backwards to find the original number. Now, going backward, we have to remember all these operations will reverse. It will be the inverse operation. Let's start with 9 and go backward. So she subtracts 3. So in going backwards, we will add 3. That means it will be 12. Before that, she added 6, but going backward, we will deduct a 6. That's 6 divided by 3. That means we'll take our final answer and multiply by 3, 18. Adds 3, so we'll take our previous answer and take away 3, which is 15. And before she multiplies a number by 3, so we will divide our number by 3. Our answer is 55. So 5 was the original number that she started with. And if you want to check, you can start with 5 and do all these calculations and you will see you will get 9. So 5 was the original number, but here don't be tempted to mark A as your answer. Read the question again. What is 6 times the original number? So 5 is our original number and you have to multiply it by 6. So the answer is 30. So our answer is C. Question number 2. 2021 is the sum of at least how many positive 2-digit numbers? Now, because we want the least number of 2-digit numbers to join together, that means we will be assuming that we'll take most of the 99s. So we finally want to get 2021. So in this case, do not attempt to divide this by 99. This will waste your time. Instead, because we do not want the exact answer, we want a approximation. So what we can do is we can take our 2000 and divide it by the nearest number to 99, that is 100, which gives us 20. So this gives us an idea that how many 99s do we want. Let's work it out. So 99 times 20, and I can work it out. 99, double of that is 198 multiplied by 0, 1980. And we can see we have already reached, we cannot accommodate another 99 to reach this number. So we have used 20 of the 99s already. How much is remaining? 2021, take away 1980. This is 4. This is 90. So 41. So we have 41 more, which of course will come from the next number. So we have taken 20 of the 99s and then we have to add another 41 to get 2021 as our answer. So that means we have added, let's work it out, how many? 20 of the 99s and another 2-digit number. That means we have added 21 numbers together to find out the answer. And this is the least that we can do. All right, the answer is B. Question number 3. Now, this is a very interesting question, and you have to use your judgment and your intelligence here. There are 5 given options here, and you have to find out which one of the following is true. Now, when I was working with the student on this question, the first very option seems like a huge one and actually difficult to understand. But don't be intimidated by this kind of question. they are trying to use up time. So they are trying to waste the time. So let's look at the easy one because we just have to find which one is true. Let's see. Let's proceed from backwards. The area of only right angles is given by base into height divided by 2. This is not true. All the triangles have this area. 4 more than the size of a decagon is the same. 4 more than decagon is 14, is the same value as the total number of sides when two heptagons are stuck together. Two heptagons are 7 plus 7, but when two are joined together, one of those sides, two of those sides will be missing. When they join, there's two sides will be missing, there will be 12. So this is not workable again. This is not true. Now see, actually, all regular quadrilaterals have sides of equal length. Now this is straight away the answer because we know all regular shapes, the very definition of regular shapes means all the angles and all the sides are equal. A regular quadrilateral is referring to a square. So we have found our answer. We actually did not need to work about what is A asking us to do. We have found the statement which is true, which is C. We are on question number 4. Natural numbers are also counting numbers and they're positive integers. For example, 1, 2, 3, 4. They are the natural numbers. The average of this, we have to find the average of the sum of the first 4 natural numbers. Let's write them down. 1, 2, 3, 4. Their total is 10. All right, and let's read the second part. And the first 5 even numbers, let me change the color. First 5 even numbers are 2, 4, 6, 8, and 10. And we can add them together. This is, I can use the method of, so this is 12 times 5 over 2, which is 30. All right, so this is the sum of even numbers, and now we have to find the average. So to calculate the average, we can have 10 and then 30 and divided by 2. So this is 40 divided by 2, which is 20. Our answer is B. Let's start question number 5. 1/5 of all the apples in a crate are rotten. 3/4 are ordinary. The remaining are excellent. If there were 200 apples in a crate, how many are excellent? Let's work it out. So let's assume the crate is a whole. Now 1/5 are rotten. 3/4 are ordinary. And the remaining are excellent. So let's add these two together, and whatever is remaining from the whole are excellent. Let's add 1/5 and 3/4. Now these fractions have different denominators, so we have to take least common multiple or use the butterfly method. You will get the same answer, 20. And on the top is 5 times 4 is 20, so 1 times 4 is 4. 4 times 5 is 20. 3 times 5 is 15. So is 19/20. So actually out of the whole, 19/20 are rotten and ordinary together. So how much is remaining? 1 take away 19/20. 1 whole take away 19/20 is 1/20. Only 1/20 of the whole crate are excellent apples. Now if there are 200 apples, we have to find 1/20 of 200 apples. And this is easily 10. There are just 10 apples which are excellent. So we found our answer, A. 10 apples out of 200 apples are of excellent quality. We are on question number 6, and this question is one of algebra. Let's see. Amanda's score was twice of Brian's score. Cassie scored 5 points less than Brian. Dora scored 10 points more than Amanda. Dora's score was 6 times as much as Cassie, whose score was 10. Now, in order to find that, let me first remove this. We'll mark it as we go along. So let's refer Amanda, Cassie, Dora, and Brian by A, B, C, D to make our life and work easier. So Amanda's score was twice Brian's score, so A equals to 2B. Then Cassie scored 5 points less than Brian, so C equals to B, take away 5. Dora scored 10 points more than Amanda, so D equals to A plus 10, and then Dora's score was 6 times as much as Cassie, so Dora's score is also 6 times of C. So these are our equations from the question. Whose score was 10? Now let's work it out. Now let's see, looking at these two equations, we can see Dora equals to 60, Dora equals to A plus 10. We can say 6C equals to A plus 10, looking at these two equations. Now we have to decide, are we trying to eliminate C or A? Now I can see eliminating. All right, we can substitute the value of C from here. Let's see. It can be easily done, 6b minus 5. And because we have to find it in one variable, let's substitute the value of A from here as well, from the first equation, so that everything turns to B and we can find the value of B. So opening the bracket, this is 6b minus 30 equals to 2b plus 10. And now taking away 2b from both sides, this is 4b minus 30 equals to, this cancels out, equals to 10. Now adding 30 on both sides, these cancels out, 4b equals to 40. And again, dividing by 4 so that we can isolate b equals to, these cancelled out, b equals to 10. Actually, the first variable we worked out turned out to be 10, and we were looking for the variable that is 10. So Brian is the person who has score of 10. But if you try to substitute any other way, if you wanted to solve this equation not by this method, by any other way, you will still find the same answer. In case you solved A first or C or D, you will then substitute the value of A, B, C, D here and find out that who has 10, and you will always see that B is the person who has, Brian is the person who has score of 10. We are on question number 7. The largest natural number formed by these digits and the smallest number formed by these digits are subtracted. Let's work it out. So from these digits, the largest number can be 5, 4, 3, 0. This can be the largest number we can make. And the smallest number, and they have mentioned that you cannot start with 0. That means for the smallest, I cannot start with 0. So we will have to go with 3, 0, 4, 5. So this is the largest, and this is the smallest number we have from those digits, and we have to are subtracted. Let's subtract them. So this is 2, 10. We have to carry again 8, 3, 2. This is a subtraction. Now in the question they're asking us what is the number formed by the first 2 digits of the result. The first 2 digits are here, 23. So the answer is A. That's our answer. We are on to question number 8. Very interesting problem. Observe the 2 shapes. The 2 shapes are given over here. Let me remove that. Find the total volume of the shapes if all equal units have the size of 3 centimeter. Now this is important that you must remember, each cube that is used has side lengths of 3 centimeter. Each of the sides are 3 centimeters. Usually in all these questions, the sides are usually 1 centimeter, but they have purposely changed the size to 3 centimeter to confuse the students. Do not get trapped by this. Assume it is packed figure. Find the total volume. Let's work it out. Let's look in the first diagram. Now we can see that 1, 2, 3, 4, there are 4 cubes right in the front, and there are 4 cubes right behind which are not visible to us. And because in the question is mentioned that they're all packed together, and there are 4 on the top. So there are total 12 cubes in the first diagram. Let's look in the second diagram. In this diagram, now consider the first row, there's only 1. The second row, there are 2 cubes. In the third row, you can see 1 cube, but there are 2 underneath which we cannot see. There are 3 in the third layer, and then you can see 2 here, and there is 1 over here. So total there are 3, 3, 6, and 9. There are 9 cubes here, and in total All right, so we have to find the total volume. So let's work it out. Total number of cubes, total volume equals to 12 plus 9, which is, and multiplied, oh, let's work it out. 12 plus 9 is 21, and 21 is not the answer. We have to find the volume. These are the number of cubes. Now each of the cube, the volume is 3 times 3 times 3, which is 27. So the total volume is number of cubes times volume of each cube. Now work it out. 27 times 21. Okay, and then 567 centimeter cube. Our answer is C. Question number 9, this is a pretty straightforward question. What is the size of the problem space, that is if you count all the possible values, how many such values are there, of the following experiment? Guessing a 4-digit ATM pin, assuming that each digit of the pin can have values from 0 to 9. Now 0 to 9, there are 10 digits. And from these 10 digits, we have to make a 4-digit ATM pin. Now, in normal numbers, if we were looking at four-digit number, we cannot have a 0 in the thousands place. But this is an ATM pin, and it can very well have a 0 in the thousands place. So for the first place, we have 10 digits to choose from. And of course, because it's ATM pin, a repetition is allowed. So for the second place, we again have 10 digits choice. For the tens place, we should not call it tens place. For the third place, we have another choice of 10 digits and another 10 digits. So we have 10,000 such possibilities. We can make 10,000 ATM pins from using 0 to 9. So the answer is A. Question number 10. Dr. Hazma, Dr. Tan, and Dr. Gupta created vaccines in their labs. Dr. Hazma's vaccine show 98% effectiveness. Dr. Tan's has 92% effectiveness, and Dr. Gupta's has 93% effectiveness. What is the probability that all three will simultaneously effective? Now, to calculate simultaneous effectiveness, we need to find out that these three experiments were effective together. So the probability of the first experiment to be successful is 98 over 100. But also because we want the other experiment to be successful at the same time, so you have to multiply the other experiment 92 by 100. That's the probability of the second experiment to be effective. And similarly, for the third experiment to be effective, we need this. Now, as we can see, this is a huge calculation to work out, and we don't actually need to work it out. Looking at these answers, there are 3 answers because we know we can work it out. So these 2 options are gone. Now there are 3 percentages given: 83, 60, and 12. Now we actually don't need to work this out. We can see that these numbers are quite close to 100. These numbers are quite close to 100. So if we had a calculator and we were about to solve, there is no way we will go to 12%. Similarly, we will not go to 16%. This is a very high percentage. This will definitely be lower than 98, 92, or 93. So that means our answer should be B, 83. Now here you have to use your judgment. Don't try to spend a lot of time actually working this out, because that would be way too difficult and you'll spend a lot of time just on this question. Look at the answers and use your judgment here. Answer is B. We are on question number 11. This is a very interesting problem, and again a problem where you have to use your presence of mind. Let's work it out. 3 pentagons are stuck together as shown below. We can see here all sides are equal and measure 3 centimeters each. What is the difference between the total perimeter of these 3 individual pentagons and the final figure? Now in this question, do not attempt, like you will get the same answer, but you will waste a lot of time if you try to work out the individual perimeter and then find the difference with what is the perimeter of this shape here. Now we already know that when they are stuck together, what is the only difference? Now, when they were apart, these two are the sides that were counted in the individual perimeters, but now they are joined together. We are excluding both the sides from our calculation. Similarly, in this joint here, there were two sides that belong to the two different pentagons, but when they are stuck together, all these are excluded from the perimeter because we will only be counting the outer sides. We will not count these four sides. So actually we have omitted four sides, and that is the difference we have from the individual perimeters joined together and the perimeter of this joint shape. So four sides equate to four sides, and each side is 3, so that's 12 centimeters. So there will be a difference of 12 centimeters. Now you could have actually gone and found the total perimeter and the perimeter of this shape, but the answer will always be the same. But if you're using presence of mind here, you are saving so much time here that you can save and use for the end questions, which sometimes demand a lot of time. A. Question number 12, we have to find the 2021 term of this sequence that is given here. Now, to solve this question, you must be familiar with arithmetic progressions. So this, let me start with this color. So this sequence starts with 7, then 9, 11, and 13. And as we can see, the common difference is 2. This series is going up in 2s. So the first term is A, and the common difference is 2. And using a direct formula, AN equals to starting term plus, because we'll be making n minus 1 jumps to reach the 2001 first term, multiplied by common difference. So we start with 7 and we make 2020 jumps of 2. So let's work it out. So this is 7 plus 4040, which is 4047. This will be our 2021 term. Let's work it out. This is C, option number C. We are on to question number 13. Which of the following numbers has an odd number of even prime factors? So we are finding all the prime factors first, looking at the even prime factors. Now, if you're wondering, the only even number which is also a prime number is actually just 2. There is no other even prime factor. So we will be basically looking at 2s, and if you have odd number of even prime factors, this is the answer. You're looking for those numbers which has odd number of these even prime factors. Now, this is the question which got me thinking, because maybe my thinking is incorrect, because I could find 3 different answers for this question. Let's work it out. Answer in the comments if you understand this question and help other students as well. All right, so if we have 182, you divide by 2, that is 91. Now, because 91 is a odd number, we cannot have a 2 again in the factors below. So we have just 1 2 in the factors. That means there's only one even prime number. So this is an odd number. So according to me, this should have been the answer also. Let's see, 442. Similarly, when we divide by 2, this is 221. Again, this is an odd number. So as we keep going on, there cannot be another even number here. So for this number, again, there is only one prime number which is even, and that's again an odd number. So this should have been correct as well. Let's look at 128, 64, 32, 16, 8, 4, 2, 2, 1. Now this is the number which has 1, 2, 3, 4, 5, 6, 7. This has 7 again. Did I do it correctly? Let me check. 32. 1, 2, 3, 4, 5, 6, 7. This number again has 7 even prime factors. So this also seems correct somehow. Let's look for 100. 250, 225, 5, 5, 5, 1. Now this is the number that has 2 even prime numbers. So this cannot be our answer. This does not work out because it has even number of even prime factors. Now let's look at 400, 2, 200, 2, 100, and actually we got to the previous question, 225, and we don't need to solve any further, but let me just write it down. So this has 4 prime numbers which are even prime factors, so this cannot work as well. So apart from D and E, according to me, all these answers should be correct. The answer which they said is correct is only C. I do not understand why A and B do not work in this case. If you have an idea for this question, please answer in the comments. We are on question number 14. Asma took part in a gymnastic competition where many people participated. When the rank list arrived, it turned out that no one was disqualified. That means every person who took part got a rank. She was the 3rd place ahead of the first of the lower half of contestants. Now, to solve these type of questions, I have found is best to actually visually draw it. So if they are saying the lower half, that means the contestants. If this is the midway, lower half, and she has to be ahead of the first of the lower half. So let's think this is our first position, like the actual first, but this is the first of our lower half, and she was 3 places ahead. That means she was 1, 2, and 3. This is the place where Asma was. So okay, so this is the person who is the first in the lower half and 3rd place ahead. Okay, and she was the 3rd place behind the bronze medalist. So now let's look at this side. So from the front, of course, because this is the first half, this is the first, second, and this is the bronze medalist. This one is the bronze medalist, and it says that she was the 3rd place behind. So now let me grab another color. So behind this, it means 1, 2, first, second, and Asma is the 3rd from the bronze medalist too. So there are 2 people in between. All right, and this is all the information that is given in the question. The first prize is a gold medal, the second prize is a silver medal, and the 3rd prize is a bronze medal. How many people are competed in all? How many people participated? Now, because we know this line divided the whole contestants into 2 parts, and now we know here are 1, 2, 3, 4, 5, 6, 7, 8. There are total 8 contestants here. So that means there must be 8 contestants on this side as well. So total are 16 contestants. Our answer is D. Question number 15. A number P is 1.5 times of Q. Let's write it down. So P equals to 1.5 times of Q. And then P is 18 bigger than Q. Let's write that down too. P is Q plus 18. And these are the 2 equations that are given to us, two clues. What is the number P plus Q? Now, in order to solve that, we have 2 variables P and Q and 2 equations. So we can, this is equation number 1. Let's see, this is equation number 2. So finding the value of P from here and equating equation number 1 and 2. So P equals to 1.5 Q. P equals to this. That means 1.5 Q must be equals to Q plus 18. Now solving this, taking away Q from both sides. This is 0.5 Q must be equals to 18. Now 0.5 Q means half Q. Half of Q is 18. That means Q must be 36. Now, if we know Q is 36, substituting this in equation number 2, we get P equals to 36 plus 18, which means it is 3, 4, 5, 54. Now, they asked us what is the value of P plus Q. So, P plus Q is 54 plus 36, which is 90. All right, we are on to section number B, which has 5 open-ended questions. So there's no multiple choice to choose from, and each question is 5 marks each. Do expect the difficulty level to rise from this question. because of course the number of marks at stake are also increasing. All right, let's read question number 16. A dancer is allowed to step only on the one of the following tiles. One is blue, one is blue, one is green, two are red, and two are orange. Let's write that down. One is blue, one is green, two are red, and two are orange, and three are gray as well. And three are gray. The gray ones are the sticky ones. So these are the sticky ones that cause the dancer to stop dancing. If the chance of the dancer that the dancer will get stuck on the very first step is m over n. Now, what is the probability of the dancer to get stuck? Let's work it out. So there are total of 1, 2, 4, 6, and 9 steps. So the dancer could have stepped on any of those 9 tiles, but the probability for the dancer to get stuck means that she has stepped on one of the sticky tiles. So there are 3 tiles, such tiles, that she can step on and get stuck. Now this is, remember they said, is equals to m over n. Do not just leave it here. We can further reduce 3/9. Do not be tempted to do 9 plus 3, because we can always solve it further. So we can divide this by 3, this is 1, divide this by 3, this is 1, and this is the fraction in its simplest form. So that means m equals to 1, n equals to 3. And now looking at the question, find m plus n equals to 1 plus 3, which is 4. So the answer is 4. 0, 0, 0, 4. This is our answer. All right. Question number 17. 5 natural numbers are chosen from 1 to 45 and they add up to 45. We have to find out the largest possible value for b, which is one of those 5 numbers across all such sets of 5 numbers. Now let's have the 5 numbers: 1, 2, 3, 4, 5. If we imagine these are the first 5, not the first 5 numbers, the 5 numbers that we have chosen, and we add them together and they are 45. The sum of them is 45. Now one of those numbers is b, and we want b to be as large as possible. Now in case we want b to be large, the sum has to remain 45. That means these places must be the smallest value possible. Now since we have to choose these numbers, we can choose smallest possible values for these: 1, 2, 3, 4. All right, now let's see. 1 plus 2 plus 3 4 plus 4 is all 10. 4 plus 3 plus 2 plus 1. That means b can be maximum 35. All right, so that is the value of b. 0, 0, 3, 5. This is our answer. Question number 18. We are building the following structure. It is a fully packed box. Back to the top of the stairs, she adds similar unit cubes to build it up to a packed staircase. She has unit cubes that fill a box. So we have these many cubes. Let's see. If we have 3 times 10 times 11, this is the dimension of the box that the cubes are filled in. That means we have 33. We have 330 cubes at our disposal to be used. A unit cube is 1 times 1 times 1 centimeter in size. The final staircase she makes was 10 steps high. That means we can see that this is 1 step high, these are 2 steps, 3 steps, 4 steps. The next column will be 5 steps, then 6, 7, 8, 9, 10, and that will be the final step of the staircase. The final staircase she makes was 10 steps high. What was the length of each step in her structure? So we have to find what will be the length of our structure. Now to solve this problem, it will be a better way if we consider it layer by layer. The first layer is if we cut the dimension all from here. So that's the first layer. Now we can see, focusing just on this part, there's 1 here, there's 2 cubes here, 3 in the next step, 4 in the next step, 5, 6, 7, 8, 9, and 10. There, in just the first layer, we have all these cubes already used. Now to add these up, remember this is an AP. We can use the formula. The first n natural numbers, n plus 1 divided by 2, which is there are 10 numbers. So this is the formula. This is 2 times 5, which is 55. So this adds up to 55. Now we do have 330 cubes at our disposal. So how many layers of such cubes can be done? Now remember, each level requires 55 cubes and we have 330 cubes. So we can do 330 divided by 55, and that actually 50 times 5 is 50 times 6 is 300, and then another 5, that's 30, so that's 6. So that means we can do 6 layers. So already in the diagram we can see 1, 2, 3, 4, 5, and that means we can build another layer here, and that will use all of the cubes, 30 and the 30 cubes. So the answer is 6. That means 0, 0, 0, 6. This will be the answer that you'll type in the answer sheet. We are on question number 19. On the weighing scale below, the rectangle weighs 2 kg more than the triangle. Let's keep writing them down. So R is representing the rectangle, and this is 2 more than the triangle T. The oval weighs 3 less than the triangle. Oval is T minus 3. And what is the weight of the rectangle? We can see these all add up to 20 kgs. So oval and the triangle and a rectangle, they all weigh 20 kg. So we have 3 variables and we do have 3 equations. Now looking at equation number 2 and 3, looking at 2 and 3, this is equals to O and this is equal to O. Oh, sorry, we can just, equation number 3, we can say O equals to 20, take away T, take away R. This is another form of the same equation. And now looking at equation 2 and 3, we can see O, equating O and O here, we can say T minus 3 is equals to, from here, 20, take away T minus R. Now this equation will be perfect if we are able to eliminate this R from here, and that we can do using our first equation. R equals to 2 plus T, so we can substitute that value here. 20 minus T minus 2 plus T. And now we have one equation just in one variable. We can work it out. T minus 3 equals to 20. Take away T minus 2 minus T. And now we can try solve it. We can bring all the T's on one side. So T, and if we transport this here, T plus T plus T, the 3 T's are on one side and we have to move this 3 to the other side. 20, take away 2 plus 3, which means 3T equals to 21, dividing both sides by 3, T equals to 7. So the triangle weighs 7 kilograms. Let's see the question. The question is, what is the weight of the rectangle? Now we do know triangle is 7 grams, so putting back in this equation here, rectangle weighs 2 more than the triangle, so that means it's 9. So in the question paper, in the answer sheet, you will say 009. That's the answer for question number 19. Let's do question number 20. A 5-digit number is formed such as it follows as conditions. Let's have a 5-digit number: 1, 2, 3, 4, 5. It has 5 places. Let's see, A, B, C, D, E. Let's say this is the 5-digit number, and these are the places. Now it says this whole number is a multiple of 3 and a multiple of 5. That means our whole number here, A, B, C, D, E, is a multiple of 15 as well. All right. The 3rd digit is half of the 1st digit. This is my 3rd digit, and this is half of A. So I can write C is half of A, and 1 less than the 2nd digit. So C is also B, take away 1. is 1 less than second digit. Now let's look at this condition here. The sum of the first 3 digits is 13. Now it's A plus B plus C is 13. Now we do have last 2 digits as well, but I have 3 variables and 3 equations. So first let's solve A, B, C. Now A, if you want to solve A first, let's have A like this. Let's change B. Actually, I'm thinking going back, we have all these equations. C is the most common one, so let's keep C and let's change A and B in terms of C. So I can write A as 2C from this equation here. So A is 2C, B is C plus 1. I can write C plus 1, and C can be C, and this is equals to 13. Now solving this, 2C plus C plus 1 plus C equals to 13. There's 2C, 2 more C, 4C equals, this can go on the other side, 13 take away 1. So 4C equals to 12, which means C equals to 3. So we found C is 3. I can change that. So this is 3. Now since this is 3 and this was half of A, so that means this is 6, and we said C equals to B minus 1, that means B must be 4. So we have the first 3 digits. Now let's look at more conditions. The fourth digit, oh, if we have one more, the sum of the last 3 digits is 8. So let me write it in a different color. C plus D plus E is 8. Now we already know C is 3. Actually, we can change that to 3. This is 3. That means D plus E just has to be equals to 5. The fourth digit is the second largest digit of the number. All right. So second largest digit, the fourth digit, 1, 2, 3, 4. This has to be the second largest digit. We already have a 6 here. And since this number is a multiple of 15, the last digit can only be 0 or a 5. All right. Now, we know D and E together have to be 5. So and we know one of those, the last digit has to be 0 or 5. All right. So we know either this has to be 5. It can be 0, 5 like this, or 0, 5 like these. This is the only possibility. Now, in this possibility, D becomes 0, and this is not the second largest digit, and this does not fulfill this condition. That means this is out of consideration, and the answer is 5, 0. So that means this is 5 and this is 0. This is our answer, 6, 4, 3, 5, 0. The question is, find the sum of the digits of that number. Let's work that out. So 6 plus 4 plus 3 plus 5 plus 0. This is 10, 8, and 0. So this is 18. 18 is our answer. That means you will write 0, 0, 1, 8. This is the answer for question number 20. We are on question number 21, and with this question we are starting section C of our question paper. These are open-ended questions. Again, that means that there are no multiple choices. You have to work out the answer and write it. And these are some of the most challenging questions, some of the most difficult questions of the paper, and that's why they are worth 6 points each. Do expect a lot of working out to work out the answer, to find the answer. All right, let's start. Find the perimeter of each of the small rectangle within. We can see the rectangles here. Assume they're all the same dimension. So we can see there are 1, 2, 3, 4, and 5. 5 such rectangles that are joined together to make the bigger rectangle. Let me draw it again. So let's see, this is our smaller rectangle, and 5 of these rectangles join to make this shape. We have to find the perimeter of this shape here. This is our question. Given that the total area of the shape is 60 centimeters square. Now let me rub this out. All right, we know area of this shape is 60 centimeters square. Now looking at it closely, okay, let's assume the length of our rectangle is L and the width is B, or the breadth is B. Now we can see from here, look at this side here. Let me change another color. This side here, this is, if you focus on the rectangle here, this is our L. But if you focus, this is the same as 3 widths joined together. We can say that the length equals to 3 times of the width, 3 times of the breadth. All right, and that solves our problem actually. So find the perimeter. The area is 60. Now let's work it out. So the L is 3B. Now let's work out the length of the rectangle. So there's a B here, and this part is 3B. So that means for the big rectangle, the width is 3B and the length is 5B. Now we already know the area is 60. That means 3B times 5B must be 60. Now solving this, 3 times 5 is 15. B times B is B square is 60. We can divide both sides by 15, which means B square equals to 4. Taking square root of both the sides, B equals to under root 4, which is 2, since we are only accepting a positive value. So our answer for B is 2. Now let's find out. We have to find the perimeter of the smaller rectangle. Now we know that this is 2. That means length, which was 3 times of B, is 6. And now we can find the perimeter equals to 6 times 2 plus 2 times 2, which is 12, plus 4 is 16. So the answer is 0016. That's for question number 21. We are on to question number 22 now. A train traveling at 54 kilometers per hour passes a platform. A man is standing on the platform and he sees the train pass him in 20 seconds. Find the length of the train. Now let's visualize this problem. So if this is the train track and this person is standing here. All right, the train starts from here. If this is when he starts, the train comes in his vision, and then the train passes from his vision. This is the end of the train. The train is moving in this direction. So it takes him 20 seconds for the start of the train to go from here to here. The whole length of the train passes before his eyes in 20 seconds. So that means the length of the train will be the distance traveled by the train in 20 seconds. This is what we need to find out. Now let's clear this. All right, we already know the speed is distance over time. Now this speed is 54 kilometers per hour, but our time is given in 20 seconds. So we will have to change our units into seconds, and also we have to find the answer in meters. So we have to change this into meters and this into seconds. How can we do that? So this is 54. To change kilometers into meter, we'll have to multiply by 1,000, and to change hours into seconds, we have to multiply 60 by 60. 1 hour has 60 minutes and 1 minute has 60 seconds. Now, don't try to actually multiply them together. There is an easier way. Let's try to cancel the common terms from numerator and denominator. These zeros do get cancelled out. There's a 6 here. 6 times 9 is 54. And 6 and 9 can get cancelled by 3. 3 times 2 is 6. 3 times 3 is 9. So this is 30 divided by 2, which is 15 meters per second. This is the speed of the train. Now using the formula speed equals to distance on time, we have to find out how much did this train travel in 20 seconds. So if this is in 1 second, the train travels 15 meters according to this. So in 20 seconds, this will be 15 times 20 meters. 15 times 2 is 30, and this x to 0, so 300 meters. This is our answer. So 30300. This is the answer that you will put in the answer sheet. We are on question number 23. How many ways can we go from the dark square at the top? We'll start from here. At the bottom of the grid, we can only move right or down. So the only directions we can move are right or down. These are the only possible movements, and only along the grid lines. So you can only move on these spots here. All right. No backtracking is allowed. No moving through the same section more than once. All right, now let's work it out. So if you start from here and you have to reach here, let's work it out. How many ways are for you to reach here? There's exactly one way. Similarly, from here, you can reach here only in one way. All right. Similarly here, if you start from here, because this is the same square, you'll be able to reach one here, and similarly one way here and one way here. Now it starts changing, becomes a little bit more. How many ways to reach here? Now you can reach from this way or down from here. So there are exactly 2 ways to reach here. And how many ways to reach? This was also 1. How many ways to reach here? Now you can come down from here or go from this way. So this is 2 ways. And now to reach here, you can come down from here or go from here. So that is again 1 plus 1, 2 ways. But again, you can also reach it from here. You can go down here, that's 2 ways. And because it's the same square, you could have actually come from here, that's 2 ways. So there are 3 entries to this square. So you can reach this point, or this point. So there are 2 plus 2 plus 2. There are 6 total ways. So your answer is 0006 for question number 23. All right, we are on question number 24, a very interesting problem. Let's begin. A 4-digit number is in the form of AABB. And it's a perfect square. What is the square root of AABB? Now let's look at the question carefully. So the number is in the form of AABB. What it means is that the first 2 digits are the same and the last 2 digits will be the same. Now in order to solve that, let's first expand the number. So using the place value, so this is ones, tens, hundreds, and thousands. So let's expand the number. So this is 1000A, again the same digit, 100A, and then 10B, and then B again. So because these are like terms, we can add them together. So they are 1100A and 11B, and we can see there's a common factor of 11 which we can pull out. So inside is 100A plus B. Now this is our number that is reduced to. Now since they have told us that this is a perfect square, that means the number we have inside should have all the factors in pairs, so that we can actually do the square root and find a number. So for this number to have factors in pairs, we already have 11 out here. That means from the bracket here, we must have another 11 that will join up with this 11 here, and that's how we'll have a factor pair. And because it has to be not 11 square but any number square, that means it has to be another n square. So we do not know that number, but it will be square of another number, and times 11, it has a 11 pair partner outside. So let's proceed on that now. So now we know that 100A plus B must be equals to 11 times some n square. So this is the equation that we're working on. Now n can only have certain values. We have only certain values that we can give to n. 3, 4, 5, 6, 7, 8. Now let's proceed from that. And remember, our a is a digit here, b is the last two digits, so they have to be single digit numbers. They have to be single digit numbers in order to form our number, the 4-digit number. Let's put n equals to 1. If n equals to 1, for n equals to 1, this here will become 11 times 1 square, which is just 11, which does not fit into our 10a plus b, because in this case a has to be 0 and 0 cannot be the value of a, so this does not work. N equals to 2. Let's try. 11 2 square is 44, and this does not work on the same grounds that a will be 10, a will be 0, and also we'll see later that this will mean b equals to 44, but as we know, b is a single digit number that has to form our 4-digit number, so that means 44 is not possible. N equals to 3. 11 times 3 square, which is 999. Again, the similar kind, we cannot accept 99. N equals to 4. 11 times 4 square is 11 times 16. Add them together, 176. Now this is a number where if I put this here, if I try to solve it here, yes, a can be, we can write it as 100. 1 times 100 plus 76. The only issue is a is 1, but in this case b is 76, which cannot be acceptable. B has to be a single digit number. So we are looking for a number here that where a and b can be both single digits. 11 times 5 square is 11 times 25. And again, using our trick to multiply, this is 275. Now this is again 2 times 100 plus 75. A is 2, but b is 75, which we cannot accept. N equals to 6. 11 times 36, using our method. Multiplication by 11, this is 396, can be 3 times 100 plus 96. Again, b does not work here. We'll keep on substituting. N equals to 7. 11 times 7 square, which is times 49. 4 9 is 13, which changes to 539. So 5 times 100 plus 39. Again, it does not work. Let's try n equals to 8 here. So 11 times 8 square, which is 11 times 64, which is 6 4 10, so it becomes 704, and this can be written as 7 times 100 plus 4. And as you can see, equating is to this equation that you've been working on. In this scenario, yes, a equals to 7 and b equals to 4, so this can work for us. We have got both single digits, and let's try to put this back into our original number and see if it works. So a b b, if a is 7, that means our number is 7 7, b is 4, 7 7 4 4. This is the number that has come. What is this? The square root of square of, not square root, square, it is should be the square of 11 square, putting it here, times we had put n equals to 8, so 8 square. Let's check. 11 square and 8 square, that means 11 times 8 square, which is 88 square. So 7744 is 88 square, which it makes it a perfect square, and we are following the pattern AABB. All right, you can go ahead, check 88 times 88, and you'll get the same answer. So the question was, what is the square root of AA? BBA, the square root is, the number is 7744, but the square root is 88. So our answer is 0088. This is our answer for question number 24. We are on to the last question of the paper, question number 25. Let's read it. Read the sentence carefully. If you take the GCD, or which is HCF, highest common factor of two numbers, you are left with numbers that are co-prime. Now, to understand that, they have given an example. Let's understand that. If you have the number 50 and 70, let's write them down. If you have the numbers 50 and 70, the underlying co-primes are 5 and 7. How did you get that? Now we know HCF, highest common factor of 50 and 70, is 10. So 10 is the highest factor that can divide 50 and 70 as well. Now to find the co-primes, you have to divide 50 by the HCF, which is 10, so you get 5, and 70 again divided by the highest common factor, and you get 7. So these are the underlying co-primes. Now do take time to understand what has happened here, the example here which I've shown, and then we will proceed. You can pause the video, understand it, and then let's proceed on. Now let me take this away. All right, to proceed on, the problem at hand is two numbers that add to 1085. So we have two numbers, let's say A and B, and they add up to 1085, and their highest common factor, or the GCD, is 35. What is the average of the underlying co-primes? Now, to find the underlying co-primes, we first need to work out what is A and what is B, what are our two numbers. Now, it is sure that if it's a multiple of 35, that means A has to be a multiple of 35 and B has to be a multiple of 35, because 35 is the highest common factor, and their sum must be equals to 1085. Now, in order to proceed to that, 35, if we're counting in 35s, 1085 is not a high number, and we can actually write down all the multiples of 35 and proceed from there. 35, 70, you can add 35 each time, and 105 add 30 and 5, 140, 175, 210, 245, 280, 315. Yes, this is the last question, so this will take a bit of time to work out. 455, 490, 525. And adding 35s is actually not very tricky. You can add 30 first and then the 5s. It's going quite quickly. Already on 700, 735, and 770, 825, 840, 875, 910, we're almost there. 945, 980, 1015, and the last 1050. If we move and the last one is 1085, of course, but then we can't have two numbers. All right, so these are all the multiples of 35, and our A and B have to come from this list of numbers. Now, if I choose, like, this was a funny question, because what happened was, if I choose 35, how much more do I need? If this is A, how much more do I need to make 1085? I need 1050, and that is actually on our list. So the first pair we tried to find, this worked for us, A and B are multiples of 35. But what I noticed was, actually, if you keep going on, if you pick the second number, 70, if this is your A, you need 1015 more, and that is also on the list, 1085. And as I proceeded on, I actually saw that all these numbers have their partners here that will add up to 1085. And let's go on to the next one, 140. If you add to 945 will add up. So you will actually get multiple pairs of A and B that will add up to 1085. So that's just not one pair, there are multiple pairs possible. But does that change our answer? Let's read the question. What is the average of the underlying co-primes? Now let's find the co-primes. Let's see if we take this example, the first one. So our highest common factor is 35. So if we find the coprime 35 divided by 35, this is 1, and 1050 divided by 35, let's work it out. It is this is 30. 35 times 30 was 1050. Now we are finding the average, so that means we have to add 1 plus 30 divided by 2. 31 divided by 2 is 15.5, and because we have to round it off to the nearest whole number, this rounded off to the nearest whole number, because it has a 0.5, it will round up, so the answer is 16. But let's see if I actually took the second option, does that change my answer? So if a equals to 10, the underlying coprime is 70 divided by 10, and that's 7, not 70 divided by 10, sorry, 70 divided by 35, that's our HCF, so that's 2, and 1015 divided by 35, it's just the one before, so it's 29. And to find the average, you are doing 2 plus 29 divided by 2, which actually turns out to be the same, 15.5, which rounds off to 16. So as you can see, if in all these pairs, A will, if you go to the next part of A, next number in the sequence, from here you're going behind. So in finding the coprimes, this will keep increasing and this will keep decreasing, but in the average, the total will always be 31, and the answer will be 31 divided by 2. So you will always end up with 15.5, which will round up to 16. So this is our answer, 0016. With that, we have finished the mock test paper for AMO. And good luck for your exams. Do like and subscribe my channel. I will be uploading solutions to other mock tests as well. So if you have any question or if any concept was unclear to you, leave a comment and I'll try to explain it more. All the best. Well, keep loving maths.